Welcome back to another lesson in MCV4U. Today we'll be talking about the derivative of y is equal to ln x, or more commonly known as ln x, or the natural log of x. And we'll discuss a little bit more about that as we go through this lesson. In this warm-up, here it tells us to find the 50th derivative of y is equal to 1 over 64 e to the power of negative 4x. And so here, if we look at our first derivative of this function, so y prime is equal to 1 over 64. Remember, when we look at e to the power of something, the first e to the power of this function stays the same. So e to the power of negative 4x, and then we derive what's inside, which in this situation is negative 4x. So we have negative 4 times e to the power of negative 4x. Here, if we look at our second derivative, it would be the same thing. So we would have 1 over 64. And now, as we're deriving it again, it would be negative 4 squared times e to the power of negative 4x. And this pattern would continue. So for the third derivative, 1 over 64, negative 4 to the power of 3 times e to the power of negative 4x. And so we continue that pattern, and we're looking at the 50th derivative. So here, with our 50th derivative, y, right, 50th derivative will be equal, and we follow the same pattern to 1 over 64. Here it would be negative 4 to the power of 50 and e to the power of negative 4x. And so that would give us, we can rewrite this 64 as 4 to the power of 3 times negative 4 to the power of 50 e to the power of negative 4x. Here, the negative 4 to the power 50 over 4 to the power 3, we can simplify that to be equal to 4 to the power of 47 using exponent laws with the same base multiplied by e to the negative 4x. And so in this second example, the second warm-up question, same idea, it says find the 20th derivative of y is equal to e to the power 3x. So here we see that our first derivative, y prime, is equal to, so e to the power 3x times 3, so it'd be 3e to the power of 3x. And so same thing, our second derivative would be equal to 3 squared e to the power of 3x. So here, if we get to our 20th derivative, so y 20th derivative equal to 3 to the power of 20 e to the power of 3x. Okay, so recall from the last lesson, again, e is called the natural number or Euler's number. And again, it's similar to, again, another rational number like pi. And so Euler's number, if you put it in, will give you approximately 2.71828 as an actual value, but it continues on, just like how pi would as well. And remember, the derivative of of y is equal to e to the power x is the same thing. So when you derive e to the power x, the derivative is the same. So recall that any exponential function can be rewritten in log form. So if y is equal to b to the power of x, then it can be also written that log base by is equal to x. So for example, log base 525 means if my base is 5, what exponent would I need to get a result of 25? So also recall that if a log is written with no base, it's the common logarithm and it's base 10. So anytime you see that it's just written as log by itself, then we can assume that there will be a base 10 that is there. Again, here we see that algebraically, we see that many laws must be used again when manipulating logarithms, and we looked at a few of these in the previous lesson as well. And so again, there's the change of base formula, power law, the product law, the quotient law, and these different log rules that are provided here. So log base b of 1 is equal to 0, log base b of b is equal to 1, log base b of b to the power of y is equal to y, and b to the power of log base bx is just equal to x. So these are important to keep in mind as going through these examples. So just like that there. Okay, so let's look at a couple of examples here. So here we have log x to the power of 5. And so here we can use the power law where we move the 5 to the front. It'll give us 5 log x. And here we have log base 4 of 9. And we can rewrite this as log base 4 of 3 to the power of 2. So we can write this as 2 log base 4 of 3. Or another way that we could write this is if we use the change of base formula, we can also rewrite it as log 9 over log 4. There's a couple ways to rewrite these types of examples. The natural logarithm, so again here, if y is equal to e to the power x is an exponential function, then we must have an inverse logarithmic function of base e. So log base e of x is equal to ln x, or again pronounced as ln x, and known as the natural logarithm. So again, here, known as the natural logarithm. So again, all log laws apply to ln x as they would for any other logarithm. Except again, here, we're using this as, again, for base, anything with a base e. Okay, so if we look at this first theorem here, you see that if y is equal to ln x, then dy over dx is equal to 1 over x. And let's look at the proof here. So here, if we have y is equal to log base e of x, which is what we're looking at here when we're looking at the natural log. And here, if we e to the y is equal to x, here what we can use is we can use implicit differentiation. And so here, if we look at this, if we have e to the power of y dy over dx is equal to 1, and here we know that dy over dx will be equal to 1 over e to the power of y. So we're replacing this here, and then replace y here. Again, replace y with ln x, with ln or ln x. So here we'd get dy over dx is equal to 1 over e to the power of ln x. And if we recall one of the log rules, or log laws. So if b, the power of log base b of x, is equal to x. So here we will see again that dy over dx is equal to 1 over x. So that's just something to keep in mind as we go through these questions here. The second theorem here is if f of x is equal, oops, so if f of x is equal to ln of g of x, then f prime of x, will equal to 1 over g of x multiplied by g prime of x. So again, similar to what we've been doing before, the derivative of the outside and then the derivative of the inside. So let's look at a couple of examples here. Here we have y is equal to ln of 3x. So y prime is equal to 1 over 3x multiplied by the derivative of 3x, which is 3. 3's will cancel out. So here, our answer is 1 over x. In b here, we have y is equal to ln 6x minus 4. So y prime is equal to 1 over, what's inside the brackets, the situation at 6x minus 4. And we're going to derive 6x minus 4, which would just be 6. Here we can simplify. So we factor out the common factor from the bottom, which would be 2. We're left with 3x minus 2 times 6. 6 will be able to cancel out with the 2 to simplify to 3. And so we'll get a final answer of 3 over 3x minus 2. Okay, so let's continue here. So here we have y is equal to ln of x squared plus e to the power of x. So here we have y prime is equal to 1 over, again, everything inside the brackets, it would be x squared plus e to the power of x, and then multiplied by the derivative of the inside. So x squared, derivative of that is 2x, and the derivative of e to the power x is simply, again, just e to the power of x. So here we write that at the top, we have 2x plus e to the power of x over x squared plus e to the power of x. So next we have y is equal to 5x cubed ln of 10x squared. So here we're going to have to use the product rule. So here if we label 5x cubed as a, and we label the natural log of 10x squared as b, we know here that using the product law, remember y prime is equal to a prime b plus a b prime. So here we'll rewrite this. So we have y prime is equal, so a prime. So here we will get 15x squared and times that by b itself, which is just the natural log or ln 10x squared. And then we're going to add by a by itself, which is just 5x cubed, and the derivative of b. So the derivative of b, remember that's going to be 1 over everything inside the bracket, which is 10x squared, multiplied by the derivative of the inside, which will be 20x. So here, let's simplify a little bit. So here we'll have 15 squared times ln, oh sorry, ln 10x squared plus, so 5 times 20 will be 100, and we can add the exponents, so x to the power of 4 over 10x 2. So here that can simplify, so that will give us 10 and 2. So here we'll get 15 x to the power of 2 times ln 10x squared plus 10x squared. So here we can draw the common factor of 5x squared, and we'll be left with 3 ln 10x squared plus 2. Okay, so let's keep going. Let's look at this example E here. So y is equal to the natural log of cube root x to the power of 5. And here, the first thing we want to do, the best to simplify first for beginning. So we can rewrite this as exponent. So here we would get natural log x to the power of 5 over 3. Again, using the log laws, which apply to the natural logs as well, move the 5 over 3 to the front. So give us 5 over 3 natural log of x, or mod x. So here, if we derive this, so y prime is equal to 5 over 3, and the derivative of ln x, which is just 1 over x, there as well. So we can rewrite this as 5 over 3x. So remember, again, let's try here. Remember, log laws apply to natural log as well. Okay, example number 2 here. It says, determine the equation of the tangent to y is equal to ln x squared over 3x at the point where x is equal to 1. So the first thing you always want to do is you want to determine if you can simplify this particular expression. And so let's simplify this. Here we have y is equal. We can rewrite this as 2 ln x over 3x. And so here we can rewrite this as 2 over 3 ln x, or sorry, ln x over x. And so let's find the derivative there. So y prime is equal to 2 over 3. And now we're going to use the quotient rule. So in the quotient rule, we are going to derive top first, which is 1 over x is x minus top just stays the same. Derivative of the bottom of derivative of x, which is 1 over the bottom squared, so x squared. Here we see that the x's will cancel out. So here we have 2 over 3, 1 minus ln x over x squared. And so here, another thing we can do first is then we know that it is at the point where x is equal to 1. So let's sub that into our equation. So the y value when x is equal to 1. So ln 1 squared is 1 over 3 times 1. So the natural log of 1 is equal to 0, and 3 times 1 is equal to 3. And so that will give us 0. So our point will be at 1 and 0, which we can sub in to find our equation of the tangent. So here we found again the derivative, which is our slope. And again, that's at x is equal to 1. So y prime at x is equal to 1 will help us determine the slope of the tangent. So 2 over 3, 1 minus ln of 1 over 1 squared. Here we have 2 over 3, 1 minus 0 over 1. It's just 1 over 1. So here we'll just be left with 2 over 3. So again, now we have to find the equation. So y is equal to mx plus b. You know that y is equal to the slope that we just found is 2 over 3 x plus b. We're going to sub in the point that we found, which was 1 and 0. So y is equal to 0. So 2 over 3 times 1 plus b. So therefore, b is equal to negative 2 over 3. And our equation is therefore equal to y is equal to 2 over 3x minus 2 over 3. And so that is the equation of the tangent to y is equal to ln x squared over 3x at the point where x is equal to 1. Okay, so let's take a look at a couple more a couple more challenging questions. So here it says differentiate y is equal to the natural log of 4 root x cubed plus 3x minus 1 to the power 5 over cube root e to the power of 8x minus x, 3, x to the power 3. So again, the first thing to do is again to first simplify. So first to simplify by using log laws. Okay, so first thing we want to do again is we want to rewrite this. We're going to rewrite this in exponential form and get rid of the roots. So the natural log. So we can rewrite this as x cubed plus 3x minus 1 to the power of 5 over 4 over e to the power of 8x minus x cubed to the power of 1 over 3. So remember, here, again, if we have this, we can apply the quotient law. So we'll apply the quotient law. So we can rewrite this now. Let me use different color, actually. So here we have y is equal to natural log x cubed plus 3x minus 1 to the power of 5 over 4 minus natural log or ln of e to the power of 8x minus x to the power of 3 to the power of 1 over 3. And so here what we did is, again, let's write this on the side, we applied the quotient law. The next thing we'll do is we'll apply the power law, so we'll move the exponents from the top to the front. So let's rewrite that. So we can rewrite this now as y is equal to 5 over 4 ln x cubed plus 3x minus 1 minus 1 over 3 ln e to 8x minus x to the power 3. So here we applied the power law. Okay, so now that we simplified it a little bit, now we can derive the equation. So here we have y prime is equal to 5 over 4. Remember, when we look at the ln or natural log, we do 1 over whatever is inside the brackets. So here it's x cubed plus 3x minus 1. Then we multiply that by the derivative of the inside. In this situation, it would be 3x squared plus 3. Here we do the derivative of the second expression or second term here. So 1 over 3 times then 1 over everything on the brackets, e to the power of 8x minus x to the power 3, and the derivative of the inside, which will be e to the power of 8x times, again, the inside, which is the derivative of 8x, which is 8, minus the derivative of x cubed, which is 3 squared. So here we can factor out a 3. So if we factor out a 3 here, we're left with x squared plus 1. So 3 times 5 would give us 15. So y prime is equal to 15. And at the top, we would have x squared plus 1. On the bottom here, we have 4x cubed plus 3x minus 1. And we would subtract that here with 8 e to the power of 8x minus 3x squared on the top over the bottom. We factor out again, or we have the 3 on the outside. So here we have 3 e to the power of 8x minus x cubed. And that would be our final answer for the derivative here. So again, first thing you want to do is you want to simplify as far as possible using the log laws, and then you can derive it based on the understanding of the natural log rules as well and the derivatives.